So, hi developers. So today, let us discuss about solid principles. Um, so let's see how a class looks like without applying a um, single responsibility principles. So we got a users class. Um, we got two methods: save to database and send welcome email. So any of these functionalities of save to database or send welcome email changes are we need to change every time, modify this class every time if any one of these methods changes, right? So let's see how a class looks like after applying single responsibility principle. First, go through a basic definition. A class should have only one reason to change. This means a class should be responsible for only one functionality or one part of the system. If a class handles multiple responsibilities, changes in one responsibility can affect the other, making the system fragile and difficult to maintain. So we got a class that is user, um, and also we have segregated the responsibilities of saving database into one class that is user repository, and another class that is email services. So um, if we are making any changes to the send welcome email, we are only making changes to this particular class. This user repository a class will not be affected. So this way we can achieve single responsibility principle. Let me quickly execute mm, um, the single responsibility principle. So here is the code. Um, so same users to database and sending welcome email to the email.com. So now let's go for other one, that is open or close principle. Let's see how a class looks like without applying open or close principle. So we got a payment processor method, payment processor class, and inside we got payment process payment method. So which takes the input type payment, which just takes input as takes payment type as an input. So here, tomorrow if you want to extend, if you want to add debit card, we need to change the existing main processor. So, so this is basically against open close principle. Let us see how a class looks like when we apply open or close principle. So first, let's go through the definition. Software entities, classes, modules or functions should be open for extension but closed for modification. This means two things. So open for extension means we should be able to add new functionality. Closed for modification, existing code should not be changed once it is tested and working, right? So for that, what we have done is we have created a interface called iPayment. iPayment has the method called process payment, and we got two classes that is extending iPayment, and we implemented uh, process payment process payment inside the credit card payment. So let us say tomorrow if we want to add a new functionality that is making payment uh, through UPI, what we simply do is we just copy, uh, we just create a new class that is UPI payment, and this way we are able to add a new functionality into the system without modifying any of the code inside credit card payment or PayPal payment. Let us see now let us execute open or close principle. Yeah. If we add a new functionality, just um, an object for UPI pay payment. So we have extended the new functionality without changing any of the existing code. So now quickly go for let's go substitution principle. So let's see how a class looks like without applying LSP principle. So here we got a class that is a bird, a sparrow, and a penguin are both are birds, but a penguin cannot fly. So if we are implementing a bird to the when we are extending when we are inheriting the properties of bird into the penguin base class, we get an exception because if a penguin cannot fly. So if I execute this piece of code, we are getting an exception here um, because a penguin cannot uh, fly. So even though penguin is a bird, we cannot implement we cannot implement the fly method of a bird class. So to overcome this particular problem, we need to follow LSP principle. Let's see how a class looks like after applying LSP principle. So the basic definition of LSP principle is subtypes must be substitutable for their base types without altering the correctness of the program. This example actually demonstrates the Liskov substitution principle correctly because because uh, birds does not assume all birds can fly. Only birds that can fly implement I flying bird, so the design is clean. So we have created a class, empty class for bird, an interface called I flying bird. The sparrow can fly, so it is a bird and also it can fly. So we have implemented I flying bird. A penguin is a bird, that is true, but we are not implementing I flying bird. So this way we can have a clean design. Let me quickly execute this piece of code. Um, Please ignore this particular statement. Ostrich cannot fly. This it should be a penguin is swimming and sparrow is flying. So this is LSP principle. Now go for interface segregation principle quickly. Let us see how a class looks like without applying interface segregation principle. So we got a class that is all printer. We are implementing iMachine. iMachine has three methods, that is print, scan, and fax. So when we implement iMachine, we are unnecessarily implementing scan and fax because an old printer cannot have scan and fax, right? So it only can implement it can only has the functionality of printing. So unnecessarily we are implementing scan and fax methods. So let us see how a class looks like after applying interface segregation principle. So when an interface contains too many methods, some classes may be forced to implement methods that are irrelevant to them. So this leads to a poor design, unnecessary code, and maintenance problems. So ISP encourages splitting large interfaces into smaller and more specific interfaces. So we got three interfaces, that is iPrinter, iScanner, and iFax. We have segregated into three of them. So um, let us say for this multifunction printer we do not require ifax, right? So simply we remove ifax implementation and its corresponding method. Okay, so let me quickly execute this particular functionality, that is ISP. Yeah, so now I need I have the flexibility to remove this fax functionality here and execute the piece of code. So printing document, scanning and scanning document. Got it. So let me comment out and also now let's go for the last one, dependency inversion principle. Let us say how does the class looks like without dependency inversion principle. So as you see, without a DIP notification class is tightly coupled with without DIP email services. So if you make any changes inside this without DIP email services, that get, let us say if we make any changes to the uh, class name tomorrow, if you want to make any changes to this particular um, class name, so all the classes that is tightly coupled with without DIP email services need to be changed if you want to make any modification to the name of this class. So what does this um, um, as you see here, if you want to change, now we can see that without DIP is tightly coupled, notification is tightly coupled to without DIP email service. If you want to change the way we send notifications using send email instead of SMS, using SMS instead of email, we would need to modify without DIP notification class. Yeah, so without DIP notification class, um, which also violates open or close principle. So let's see how we can resolve this problem. Um, so dependence in universal principle says this principle states two rules. High level modules should not depend on low level modules. So since our notification is a high level module, it should not be depending on low level modules. So both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. So what I have done is we got a class called notification. Notification is uh, um, so what I have done is I created an interface that is iMessage service, right? So the class email service is implementing iMessage, iMessage. So we got a method here, send message. So now we are not directly creating an object for email service here. So we are creating an instance for iMessage service and uh, sending an object of email service to iMessage service instance through dependency injection. So this way, this notification service, which is high level module, is not directly depending on low level modules. It is depending on abstraction. So let me quickly execute this piece of code also. So I'm explaining you about the dependency inversion principle. Yeah, that's all, guys. This is end of the tutorial. Thanks. Bye. Take care.